Welcome to the Explainer. If you've ever felt that soul-crushing pain of staring at a beautifully detailed markdown checklist in your project documentation, only to realize you now have to manually copy and paste every single item into Azure DevOps as an individual task, well, you are definitely in the right place. Today, we're looking at a brilliantly engineered solution to that exact problem. The hero of our story is a .NET 10 application called Insert Tasks on Work Item. We're going to trace exactly how this tool seamlessly connects your static documentation right into your active sprint.
All right, here's our roadmap. We're going to bridge the gap between Docs and DevOps, map out the 5 core engines, trace the automated task journey, track dependencies and environments, and finally, do a quick corporate reality check.
Section 1, Bridging Docs and DevOps, Solving the Disconnect. Seriously, think about the sheer number of hours, honestly, probably days, your team wastes manually bridging the gap between what you plan to do in your documentation and what you actually track in Azure DevOps. It is a massive, frustrating bottleneck, and this tool was built specifically to eliminate that friction.
So what is it?
At its core, Insert Tasks on Work Item is a .NET 100 application that essentially acts as the connective tissue between your wiki and your actual ADO sprint. It literally reads your markdown task checklists and automatically converts them into real, actionable Azure DevOps work items. No manual data entry required at all. Section 2, the 5 core engines, mapping the data pipeline. Let's actually graph out this entire system architecture as a sequential pipeline, looking at exactly how these connecting points hand off data. Node 1 is config. .env completely eliminates setup friction here by auto-generating your local environment variables on the fly. That data passes seamlessly to Node 2, off, which unlocks access and hands the token over to Node 3, API fetch. This is where your live Azure data gets pulled in to feed Node 4, the ingestion engine. Finally, all of that process data flows down to our terminal node, report generation, outputting a completely dependency-free HTML audit. It is just a perfectly linear, seamless handoff of data. Zooming in on that second node, authentication. Under the hood, this pipeline is using interactive browser credential. If you haven't used it, it's this incredibly sleek, modern feature from Azure.Identity that securely opens a loopback browser window specifically for intra-ID OAuth authentication.
So why does this architectural connecting point matter? Well, utilizing that modern OAuth standard via intra-ID is vastly superior to the legacy method of hard-coding personal access tokens, or PAT keys. You really don't want sensitive keys just floating around in your source code or text files. This loopback method securely handles the token exchange without ever exposing long-lived credentials. All right, moving down our graph to Node 3. Once we're authenticated, the API client uses WIQL, Work Item Query Language. This is the exact syntax the v7.1 REST API needs to pull down your specific projects, your active iterations, and those parent tasks. This query essentially acts as the connecting bridge that grabs the raw material for our next step.
Section 3, automating the task journey from markdown to work item.
Now, what's really interesting here is how we can structurally graph out a single piece of text going through this transformation. Just trace the flow. Our input is raw markdown straight from an Azure DevOps wiki, just a simple text string being handled by wikitaskextractor.cs. Then, moving to the transformation stage, the ingestion engine cleans up that text array and maps it directly to a target story ID. Finally, the output node pushes a live ADO task work item right back to the cloud, perfectly linked to its parent using a hierarchy reverse relation. It's a beautiful, completely automated transformation. Bringing this back to your day-to-day, this pipeline completely unlocks spec-to-task automation, meaning your raw meeting notes can literally become track tickets. It enables release readiness gates to ensure absolutely no code ships without an approved pull request. It even paves the way for advanced supply chain audits and deployment artifact reconciliation, which is exactly what we're going to look at next. Section 4, tracking dependencies and environments, the analysis engines. If we look at this as a structural graph to compare our two analysis engines, you can see the exact connecting points they use. The dependency analyzer takes the package.json from your active branch and compares it against the target build. Boom, it instantly identifies any version drift, what was added, updated, or removed. Meanwhile, the environment comparer takes the target build ID and physically validates the artifact drop paths right on your network. It guarantees those files are actually sitting where they are supposed to be before you trigger a release.
But hey, what happens when the API inevitably goes down or you lose internet access? Well, the architecture features this brilliant safeguard called resilient graceful degradation. If the live API validation fails, the pipeline doesn't crash. Instead, an app response wrapper steps in, intercepts the failure, and seamlessly injects high-fidelity mock data down the pipeline. This demo mode fallback means you can keep developing and testing offline without missing a beat.
Section 5. Real-world enterprise limitations. The corporate reality check. Okay, we have to address the elephant in the room. Is this actually going to run seamlessly on your completely locked down corporate machine? You know, the one hiding behind that universally dreaded corporate firewall? Let's temper our expectations just a bit here. The reality is, strict enterprise environments can totally disrupt those beautiful connecting points we just mapped out. For instance, because this tool requires a browser for interactive authentication, running it inside a headless CI/CD pipeline is just going to cause it to hang. Plus, zero trust network access or Apple Opera policies might flat out block those SMB artifact drop paths we just talked about. And if you're not careful, that brilliant demo mode fallback could accidentally generate false positives in a production audit if your runner isn't explicitly configured to fail on live API errors.
In fact, the source documentation explicitly validates this with a pretty strict rule. In organizations with strict conditional access policies or restricted service accounts, token acquisition or REST calls may be blocked by SecOps policies. It's just a vital reminder to always audit your local network and security privileges before trying to deploy API automation tools. Which leaves us with a pretty compelling question to take away. How much of your team's manual project management could actually be replaced by simple API automation? Seriously, look at your workflows. Think about the hours spent just copying and pasting. The connecting points are right there, just waiting for you to build the pipeline. Start connecting those dots. Thanks so much for joining me on this explainer, and I will catch you on the next one.